Good morning, everyone. This is Tractorman44. I got a buddy. I did a little sheet metal project for him not too long ago. He had to put a little fan coil, or we had to make him a little fan coil for down in the basement. Had to make him a fitting to blow a little more heat off of his wood-fired boiler into his basement area. Well, now he's built him a sunroom on the back of his house, and needs to extend a couple of his runs that go to his perimeter registers, his 4x10x6 perimeter registers. He needs to extend those through his sill plate and onto the outside edge. And we've solved the issue on two of them, but the third one's going to be a bit of a problem. I'm going to show you a little sketch that I've drawn up, and we're going to knock him out a special fitting. And there's a reason for it, and I'll try to explain that adequately. Don't know if I'll be able to do that or not, but I'll give you an idea of what we're coming up with and the reason why. Before I show you my drawing, let me preface it by telling you that there's three basic types of boots that you distribute your air, up through your floor registers with. There's a universal boot where the 6-inch round pipe comes in from the bottom and then straight out the end of it. The universal meaning you can put a 6-inch 90 on it, and you can take it virtually any direction in 360 degree for the inlet of the 6-inch hot air pipe. Okay, well, that's a universal boot. You don't use them too often. Then you've got a torpedo boot. The reason they call it a torpedo boot is because it's not really shaped like a torpedo, but it's a long, skinny, narrow 4x10 or 4x12x6, where the 6-inch comes in one end and right straight through and up at a 90-degree angle, but it comes in from the end of the 4x12 or 4x10 rectangle. And they make a left end boot, they make a right end boot, and they make a center end boot. I usually use center end boots for everything because you can always trim them and adjust them and make those function. Then the third thing is the right angle boot, 4x10 or 4x12x6 right angle boot, where you have your floor register 90 degree to the angle to which the 6-inch comes into it. 6-inch comes into the side of the angle boot versus the torpedo boot where it comes in from the end. Well, the problem we have on Dave's third and final register is it's a torpedo boot and it goes up into a tiled area. The tiled area is not conducive to any type of work necessarily. Though he doesn't use that register too often, he wants the flexibility in the system to be able to use it in the future. So that necessitated what we're doing now. We're essentially going to have to cut that boot off, leave the register intact so we don't disturb the tiles, and then we're going to make a boot that'll clip up underneath that and then drop down low enough to allow his 6-inch run to come in up top and then yet come out near the bottom on the opposing side, to where he can roll it with a 45-degree angle to get into another joist space to roll it yet again back up to go to that register out in the mudroom, the third register in the mudroom. Difficult to understand, difficult to explain, but in actuality it's quite simple. But and this is like a utility area, so head clearance is not a major concern. Of course, we're all short people, so unless you're dang near 7 feet tall, you can hit your head on nothing that we're going to do anyway. Now I'll show you exactly what I'm kind of going to fabricate for him this afternoon. Okay, bear in mind I'm not a videographer, I'm not a professional speaker, and I sure as hell ain't no draftsman. But essentially what we're going to do is we're going to cut that torpedo boot off just a little bit below the floor joist, allow his floor registers to stay intact. I'm going to make this just a little bit larger to go all the way around the perimeter of that cut off torpedo boot, and we'll allow the registers dampers up top to control or to limit the amount of air going that direction, so that the box will fill up with air and then take out the opposing side, which will jump the joist space down below, and then with a couple of 45s and get into the other joist space to go out the Four Seasons room. But at any rate, there's essentially going to be a 6-inch opening up here where the existing 6-inch run will come in and still supply potentially this fairly unused register, yet pressurize the box and allow it to come out another 6-inch opening down here, which will supply the new register, or the third and final register, in the Four Seasons room. So now we're going to go about the business of laying this out and making it out of sheet metal. Now, there ain't just one way to make anything out of sheet metal. There's a wide variety of ways to make stuff. I'm just going to keep everything simple in this particular one. We're going to start off and we're going to make these two end plugs. If you look at it as though this will be a plug that'll insert into a wrapper, we'll make a plug, and it'll have an identical plug over there. So what we can do is make that, and then we have to measure that. Well, this is a finite dimension here. This is a given. It's 17 inch, that's 7 inch, plus this is 1 inch. So we can add those two, but the variable is this one right here. So what we'll do is we'll lay out the two side pieces, then we'll measure, we'll get our cut length of the wrapper, and then we'll go ahead and trim that wrapper and fold it, and it's going to become a 3-piece fitting with no holes except for the top, and that top right there is going to rest right over the top of the existing torpedo boot that we cut off. First thing we'll do is we'll identify the 90-degree starting point. That's going to be the lower corner where the bottom comes in contact. So anyway, we know that's going to be 7 inches, so that's going to be a 7.5, because we have to have the 7 plus the 2/4 to tie into the two lock farmers. And then the length or the height is going to be the 17 plus 1/4. So we'll lay out 17 1/4, and then we have to add 1 inch to that, so that'll be 18 1/4. The reason we have to add the 1 inch is we want to have a 1/2 inch double hem folded over flange, or leave a 1/2 inch flange for him to screw into the floor. I think we're just going to leave it the double hem. Hey, on a side note, an old dart, it makes a real good scribe for sheet metal. So we'll measure in off of that 1/4 and make 6 1/4 inch dimension, which will be 6 1/2 cut size. We can use a straight edge. We'll transfer that measurement down. We flared it out down there till we kind of get a little bit more of a width. We can shift that over just a little bit. So, and then also we have to have a 6-inch hole down here. So if I just flare that over and then go up a minimum of 6 inches, so that's going to be 6 1/4 inches up. Okay, and then this is an arbitrary dimension here also. We'll just, here's that dimension there. So if we come down, let's just say we come down 6 inches. That just makes it easy to figure. Then we'll establish that angle, and then add a 1/4 inch to both of those. Use our straight edge, our circumference rule for a straight edge. We're ready to cut that out, and then we're going to have the pattern for the two plugs. And we'll trim this out here. Okay, if you look real close, you can actually see that's the basic shape that we just laid out. This is a clear case where you have to have a left side and a right side. If you don't invert the layout side and place it upside down on your next piece of metal to outline or to trace it, you stand a real good chance of making 2 left sides or 2 right sides. So invert your piece and then trace it perfectly as you can. When you're sloppy on tracing, the sloppier you are, the less like the original your second one is. And always put an eye on it. Remember, for the inside. That way it takes away any thought required when I pick them up to fold them as to which way the folds need to go, to make sure I do end up with a left side and a right side. Say you're in a situation where you may have to make 8 or 10 or 12 of those, always use the same original one too for the pattern. If you use the different one for a pattern, your fitting is going to change immensely by the time you get to the tail end. Now, you know there's some limitation to what you can fold with your standard brake, which is why they come up with these special tools called cheek benders. If you fold this in a standard brake, you put a crease across this. Don't really want to cut that all the way off, because that's more of a potential for an air leak. So you can go ahead and crease it and tap it back out, then do it either by hand like I'm going to do, or use a cheek bender. I don't really want to get the cheek bender out for 2 little old folds, so I'm just going to do it by hand. Now the trick on folding these by hand is you don't want to round over these fittings. So you got to get a good grip on those things. And a lot of guys just grab them and bend them all the way up 90 degrees. But you don't really want to do that. You want to just a little bit of a bend, go back and get a little more. I mean, it depends on how you want your metal to look. Personally, I like my metal to look fairly decent. I don't like nasty old crinks and kinks and weird looking things like that in it. I like it to look halfway decent, you know, like at least semblance of a professional fabricated it and installed it. And to do so, you really got to take your time. But the main thing is how you use the tools. You know, like this right here, this is a pair of Pexto hand seamers. My God, they're probably older than I am, but they're good. They make a good crisp bend, but you always get a little bit of an oddity in the bend when you have to fold them by hand. And I'm really awkward doing it like this because I'm trying to stay in the view of the camera. I don't even know if I did or not. But once you get them folded, then you want to take your little block here, a good crisp block. Again, are you going to do this commercially every day on a job site? No, because you don't hardly lay out the metal like this anymore, you know. Well, some people do, I guess. But I mean, all the shops now have CNC machines and all kinds of fancy stuff, you know. I don't even know how to turn them on. But that's okay. I'm a service technician, man. I ain't no sheet metal worker. I would never claim to be a sheet metal worker. I just kind of enjoy it, you know. You take something flat and you bend the heck out of it, and sometimes it turns out to be something kind of pretty. But like I said, the trick is how you grip this stuff and how you just kind of have to visualize what's happening there, because you can make it look like hell if you don't take your time. Okay, now here's our two end pieces. So now we have to make a one-piece wrapper to go all the way around it. So anyway, I got the one-piece wrapper figured out for length. Give you a tip, what you do whenever you measure that all up and add those numbers. I get a little rusty on my numbers every now and then. So when you're laying this all out, you once you get the final scribe mark, then measure your total length and make sure that it adds up or measures out exactly what you added up. You'd be surprised how many times it does not. To refresh your memory, if you're not experienced on these machines or knows what they are, this is actually a Lock Farmer brand Lock Farmer machine that makes what's the tradesmen call a Pittsburgh lock. It takes up 1-inch material on this particular machine. As far as a rough cut is concerned, you have to add 1 inch of material to your actual width of duct because it's going to consume that, fabricating this weird looking lock that facilitates assembly. Those 1/4-inch bends that are on those end plugs we made will go right down in here. This gets bent over 90 degrees and locks the pieces together. So let's fold that up, and then we'll go back to business putting her together. This should be our one-piece wrapper. Now remember this old boy here? See how nasty that looks? But you just get that kind of bent over in the general direction, then you dial it up this old boy. Now again, what that's going to do, that's just going to encapsulate that torpedo boot where it cuts off right underneath the floor, made a little bit larger where it'd be very simple and gets him a little bit of adjustment in order to encapsulate it, to allow him to make it easier to take the 6-inch tap off of the bottom to go to the new register. Now, you might think, oh, this ain't gonna work, but really you think about it, this ain't nothing but a balloon. It's a balloon, it's not made out of rubber. So if you dump air into it from one side, it instantly is going to pressurize this and put essentially the same amount of pressure inside this box as what it is able to develop in the branch of the duct coming over here. So once it builds up that pressure, which is instantaneous, that air is going to come out the other side and go to that other that additional register in his 4-season room. That's it. All I'm going to do is take the Whitney punch and punch a couple holes in it. Give him the option anyway. Be easier on me if I lay it down. I guess you all know this is a Whitney punch. You have punches and dies come in a whole set. You pull out your die, pull out your punch, put all different sizes. I can't remember. I'm using 9/32 right now. That's pretty much a standard I use pretty much all the time. But man, that old thing there, that's close to 40 years old. And I've got one a whole heck of a lot older than that. Probably a silly little thing to make a video on, but what the heck, you know? Doesn't take much to set the camera up. Unfortunately, it's so confining in the shop. I need a little drone, you know, a little miniature drone to fly around and carry the camera. It doesn't take too awful much if you can think about it, and get it on paper, anybody that's worth the salt can just about make it for you. Might not be the prettiest in the world, you know, I don't make the prettiest of things, but it's fun, it's enjoyable. I just kind of like knocking around with it. So hey, this is Tractorman44, and I am out of here.